This video is a little on the longer side. I'm going to cover simpler equations at the beginning, more complicated equations at the end. So if you've got a doozy, maybe skip forward a few minutes. What makes polar to rectangular a little bit more of a complicated conversation is the fact that we have to make decisions. Okay, you cannot just plug these things in and hope for the best, cross your fingers and you'll win. You need a strategy, and there's two strategies. Multiply both sides by r, or square both sides. And every now and then, I said you have two strategies, right? Every now and then that's not true. There's another thing you have to do, or I don't know. Take the tangent of both sides. That's just an idea. Okay, so almost always, like 90% of the time, one of these two things is going to work. So let's see. What do we have here? Convert the equation r equals 6. Okay, well, let's try squaring both sides. R squared equals 36. Hey, I like r squared. That's right over here. That's one of these equation conversions I can use. So I could say x squared plus y squared equals 36, and I'm done. That is a rectangular equation. I don't want you to think you have to say y equals. Okay, and actually with this one, this is a good example. If you converted this into y equals the square root of 36 minus x squared, you might be feeling better because you've got a y equals, and that feels nice, but these are not equal. These are different things. One of them describes a circle, one of them describes half a circle. So be careful about snatching defeat from the jaws of victory. I want you to focus on just getting to x's and y's and then stopping. And I'll talk about cases where that's not true, but just try not to overcomplicate things and get fancy, unless there's a reason. Now let's look at this next one. Theta equals 11 pi over 6. I think it would help to first, in this case, draw a little picture of what we're talking about. Theta equals an angle, and there's no r anywhere. So r could be positive, like this, and r could be negative, like that. So we're going to get something that describes a line. Okay. Now, if you square both sides, you get theta squared. That's just beastly. If you multiply both sides by r, you get theta r, no improvement. So this is one of those rare cases where you have to do something else. And I think taking the tangent is a good idea because now we get tangent theta, and we like that. And that's just y over x. And then we have tangent 11 pi over 6 over here. Okay, so that becomes y over x equals, tangent, what was this one? Negative 1 over radical 3, I think. Now, we're not done in this case. We do need a little bit more, because this right here, this implies a domain restriction. Okay, according to this, there is a domain restriction where x cannot equal 0. Right? Remember how those work? Is that actually what this picture tells us? Well, this picture tells us it's just a line with nothing fancy going on. So we actually need to change this equation slightly to get rid of the domain restriction. I would rather see it in this form because this thing implies no domain restrictions, and that's what I want. Okay. The other way you don't have to graph it. You could just look at this thing and say, oh, theta equals a number. I'm not dividing by anything. I'm not square rooting anything. There's no domain restrictions. Okay. So moving on. Let's try squaring both sides. Worked last time. It's going to work this time, right? Maybe. R squared equals 25 sine squared. That turns out I don't love this because I don't have an easy sine squared substitution. So scratch that. And let's try multiplying both sides by r. The left is the same, but on the right, this is an important difference. I get negative 5 sine r. And I like that because I get my x squared plus y squared on the left. And on the right, this is negative 5y. Okay, and that is as far as we need to take this one. Okay. Now, you might be wondering, is there a way you can tell whether you square both sides or multiply both sides by r? I don't know. Let me know if you figure one out, because I would love to know. I think it's just practice, but that's not really a method. Okay, we're going to change this by doing a little squaring action on both sides. R squared equals 36 tangent squared. And you might wonder, why didn't you multiply both sides by r again? Well, what is tangent theta times r, or r tangent theta, right? R tangent theta is not one of these special things over here. Okay, r sine theta is great, r cosine theta, great, not r tangent. So in this case, I wanted to square both sides. And then I get x squared plus y squared equals 36 times y squared over x squared. Okay, that's it. In this case, we are done at this point. And you might wonder why is it okay this way, not the other way? See this equation that I just put in the box? That has a domain restriction in it. And there's a little hint here saying, hey, careful now. Your equation must have equivalent domain restrictions whether in polar or rectangular form. Okay, well, let me draw a picture for you. Where does x equal 0? Right, it's right on the y-axis. So I don't like that spot. That's a domain restriction. Well, think about the unit circle. Tangent squared has domain restrictions here and here. Same place tangent does. Okay, at those places, tangent, if you say tangent of pi over 2 or tangent of negative pi over 2, those are domain restrictions. They don't exist. And you can see that's where x equals 0. So these are equivalent domain restrictions, and that is why I'm not going to rearrange this and multiply both sides by x squared. I know, kind of annoying. You think that's annoying? Wait until you see this one. This is a beast. So this is actually my second try at this video. I'm gonna have to approach this one carefully. We could multiply both sides by r, but then you're gonna get a 3r over here. I don't love it. So we're not gonna multiply both sides by r. I could square both sides, and I get r squared over here. That's nice. And I get 4 squared sine squared theta with some other stuff, and that's not so great. So you're thinking, well, do I take a tangent to both sides? Well, that's terrible because you can't take the tangent of r. So let's pretend you fiddled around with it for 5 or 10 or 20 minutes and got really frustrated. Here's what I came up with. Why don't we try this? Let's add 4 sine theta to each side. And we get this. Now let's try squaring both sides. Is it going to be a little different? I don't know. Let's see what we get. I'm going to square that. I'm going to square this. See what this turns into. Remember your foiling. We get r squared plus 8r sine theta, okay, plus 16 sine squared theta. That's all the left side. The right side is nice. That's just 9. Okay, this is actually pretty good because I see an r squared. I like those. I see an r sine. That's nice. Numbers are fine. Sine squared, not so great. I've got to deal with the sine squared. But I have a way to do this. See, everything else is okay. It's just that sine squared that's a little bit of a problem. So now what I'm going to do is multiply everything by r squared. Okay, watch where this goes. I get r squared times r squared plus 8r sine theta times r squared plus 16r squared sine squared theta equals 9r squared. Well, now if you examine every single term, these are all things I can deal with. I've got x squared plus y squared times itself. Okay, that's the leftmost one. This one looks like 8y times x squared plus y squared. Okay, that's not too bad. This one over here looks like a 16y squared, and it all equals 9 times x squared plus y squared. Ugly? Yeah, it's terrible. But those strategies of multiply both sides by r, square both sides, were still our main workhorses here. We just needed a little bit of a rearrangement of this thing at the beginning. So don't be afraid to fiddle.